Okay, let's have a little look at what this logical thinking and reasoning is all about. This is an investigation and a chance for us to just explore some ideas in a little bit of detail. And obviously there's a bit more structure on this because this is from a CIM paper. Okay, what have we got then? So, grid has a letter T placed on it. Okay, that makes sense, I can see that. Oh, that's a nice black highlighter I've got there. Is a horizontal bar of length 3 and vertical bar of length 2. And the T shown in shape 1 because the number on the top left of the square T is 1. Oh, okay, so that's saying to us here that because this top left position is 1, the number 1 square, so that is shape 1. Okay. What else have we got? T values are found using this method. Square the number at the bottom of the T. If I just look without looking to the right, that suggests it's this. Yep, 22 squared. Multiply together the numbers at each end of the horizontal bar. Multiply the numbers at each end of the horizontal bar. That looks like this one and this one. Yep, 1 times 3. So we got 4, 8, 4 and 3. And then take the second answer from the first answer to find the T value. Okay. Alright, that's okay. Copy and complete this table. So when n is 3, well, we've been given 1, and we were talked through how that works. 2 is then there as well, and you can see obviously the T shape, if you imagine moving across 1, there would be a 2. Okay, fine. Let's just have a look at what shape number 3 looks like. So if I do that in green, shape number 3 is going to have to start here. It's going down. And there we have it. So what we have is we have first of all 24 squared. So 24 squared minus 3 times 5 minus, where am I? Where's my pen? 3 times 5. So that comes out as, oh, now it's testing my, I'm going to probably grab my TI Nspire here. In fact, I might just put it in like that. Put my that straight into my TI Nspire, and it's giving me a value of 561. Okay. Now what I'm looking at is I'm looking at to see if I can spot any pattern without the need to draw my T on this shape. So 22, 23, 24. Well, what's going to happen next? It's going to go 25. Squared minus, now what's happened for the first number of the multiplication? It's gone from a 1, 2 to a 3, so the next one's going to be 4 minus 4 times, and the second number, the pattern is going 3, 4, 5, and then there's a 6. Fantastic. For building it up here, and we're getting a T value for the fourth one of 601. I'm going to follow the same pattern again, and the next one is 26 squared minus 5 times 7. Plug that into my calculator, and I'm getting an answer of 641. Okay. Oop. Right. When a T is placed at the end of a line, it still has a T value. Okay. The T wraps around like this. So if it's the triangle, the T shape 9, then it still works in the same way. So I suppose we could imagine, and this fits in really nicely what we were talking about bases, if that continued, you can see that it would work for that 11 if it were in that position. Clearly it's not. It's going to have to, because we've got rows of 10, that 11 is then shifted down, as you can see from this arrow. So that kind of makes sense. So T9, therefore, using the same method as before, should be 30 squared minus 9 times 11. And that comes out as 801. Okay. When Tn is equal to 2641, find the value of n. Okay, so we need to figure out what's going on here. Now don't make the mistake I did. I didn't read this bit, did I? T1, T2, T3, T4, T5. So I guess that's the numbers that we've got. Form a sequence where it's 40n plus 441. So what we're hoping we should be able to see, whoa, don't go round, oh there we are, is it's going up in 40s. Can we see that sort of pattern here? So let's have a look at what we've got. 481 to 521, 561601. Ah, yes, it is indeed going up in 40s. So that's quite nice. Might help us get an idea of what's going on. So here we're given a formula and we're told what it equals. So we need to solve this equation. So we know that 40n plus 441 is equal to 2641. So we're looking to solve this equation. What should I do? Take away 441 first of all. I'm reaching for my calculator. You can probably do this in your head. I just don't want to make any mistakes on the video. So I'm getting 40n is equal to 2200. And then I need to divide by 40. I need to divide by 40, and I get an answer of 55. Okay, explain why 843 cannot be a t value. Okay, so we're going to see if it can work with this formula. So it was given to us, that formula. Can I plug something in to get an answer of 843? Well, let's have a look. So I might work below here. 40n plus 441. Can it equal 843? Well, 843 take away 441 is 402. So 40n would equal 402. And obviously if I divide that by 40, it's not going to work properly. It's going to give me n equals 10.5. So that's not an integer. Therefore, not a t-value. Okay, moving on. The T is now placed in a new grid that is 11 squares wide. Aha, so now what we're doing is we're applying a similar idea to different size rows, and that links really nicely to the work we did on bases. So let's have a look here. Question 2. Complete this statement for the grid of numbers. In each row, the numbers increase by 1. That makes sense to me. Complete sense. It's increasing by 1 as I go across. Doesn't matter where I am, it's increasing by 1. And each column, the numbers increase by, it's going 5 up to 16, 1 up to 12, 2 up to 13. I think that's increasing by 11. Complete the squares using t in terms of n. So it's led us into what's going on here. If this is n, this would be n plus 1, because it's 1 more. And 1 more than that, again as well, would be n plus 2. Nice. Now, we need to think about what the number is below this n plus 1. Now, let's just remember, it goes from whatever it was, so this 2, it goes up another 11. So it's at plus 1, and I need to add another 11 to that. So that's going to have to be n plus 12. And then another 11 on top of it as we go down another column. Goes as we go down that column. So another 11 adds on to 12. 23. Okay, part C then. Complete this working to show that t of n equals 44n plus 529. The first line of working is done for you. So t of n will equal n, what did we square? Let's just think about this. What did we square? We squared this thing here. n plus 23. It was the bottom value, wasn't it? So n plus 23 is going to be squared. Then we take away the two things here, n multiplied by n plus 2. I nearly wrote n plus 2 again. Okay, so we need to expand this. So, right, let's have a look. So this is, oops, why am I in yellow? I'm not sure. Undo that, blue. N plus 23, n plus 23, minus n plus 2. So just instead of writing it as being squared there, I've just written them out twice so that when I expand my brackets I can just see clearly what's happening. We had a bit of practice at this when we did our surds. So let's have a look. We've got, we've got n squared plus 23n plus another 23n plus 23 squared, 23 times 23 in my GDC, just to check, plus 529, minus, now I'm looking here, multiplying minus n times n first of all, which is minus n squared, minus 2n. So, first thing I'm noticing, I've got an n squared and a negative n squared, so they're going to cancel, disappear in a puff of maths. And what do we have in total? I've got how many n's? 46 n's, take away, so 46, if I add these and I take away 2, I've got 44 n's, plus this number here, which is 529. And there it is. We've just shown that this is what we're after. So whenever you're asked to show something, you need to arrive at that, whatever that thing is, as your final answer. You can't start by using it. You've got to use the information you've got, and hopefully you'll arrive at that answer. And if you don't, that's a good trigger to know that you need to just try it again. Okay, question 3. We're nearly done now. The T is now placed on a grid that is 12 squared wide. Find a formula in its simplest form for n. Okay, so let's just think about this grid. What I might do is I might just visualize this with my T, just to think about what's happening in my T. So there's the T shape, and what do we know? We know that this is going to be n plus 1, and n plus 2. Now when we changed up from 10 to 11, the amount that it went down by changed. So from n plus 1 it went down to n plus, instead of n plus 10 it was n plus 11. So we need to add 12 on this time to the 1 we've got, so n plus 13. And then another 12 added onto that to n plus 25. Right, what have we got then? Find a formula in its simplest term for Tn. So we need to go through that process again. So it's going to be, let's do this in blue over here. It's going to be n plus 25 squared minus n plus 2, which is n squared plus 25n plus 25n plus 625 minus n squared minus 2n. And if I simplify, same thing again, I've got 50n take away 2n, I've got 48n's plus 625. 48n plus 625. Okay, the T is now placed on the grid that is W squares wide. Show that Tn is equal to 4W squared 4n plus 1 W plus 1. Okay, let's have a look at what we've got then. First thing I'm going to think about here is what square I'm actually squaring each time, and that's this one. And what do I do to that? Well, I've always got to add 1 to go across here, and then I add on whatever the column width is, sorry, the grid width. Now it's telling me now that that's W. So I need to my N, I need to add 1, add another W, and then a second W. That's the process that I went through here. So that's going to be N plus 1 plus 2 W's, which I'm going to square. Although actually I'm looking at this hint. Is this going to help me, this hint? To save me a bit of work. Tasty. Let's have a look. So for 10 it was 20. Well, this all stays the same. That's the first thing that I'm noticing. So I need to focus here and just try and generate what's going on here. For 10 it was 21. For 11 it was 23. And 12 it was 25. So for 10 I've added 11. For 11 I've added 12. For 12 I've added 13. So I just need to add on one more than whatever the width is. Oh, that's quite helpful, I think. I might erase what I've just done and have another look at seeing if I can do this now with a different approach. So it's going to be N plus, now what did I say? Whatever the width was, it was that plus that 2 of them and another 1. Yeah? Is that what I said? Let's go through it again. So if I take 10, multiply it by 2, that's 20, and I need one more. If I take 11 and multiply by 2, that's 22, I need one more. If I take 12 and multiply by 2, that's 24, so I need one more. So it's N plus 2W plus 1 squared minus N plus 2. And all I've done for the second section here is I've now called it here. So what we said is it's 2 times whatever the width is squared minus N plus 2. And this is quite tricky for us, but we can have a go. Process the same as before. Let's multiply out our bracket. So N plus 2W plus 1, N plus 2W plus 1, minus this thing, N plus 2. So what do I need to focus on? What's the multiplying out of these two brackets? Thing to remember is make sure you multiply everything by everything within it. So I would work across this first one, each time making sure that each term in the first one multiplies by all 3 terms in the second. So let's give it a go. First of all then, I said N times N. So if I get my pen, that's N squared. What else have I got? Next, I've got N times 2W. So that's 2WN. Next, I've got, that is a W, N times 1, which is just an N. Okay, so that is this term multiplied by each of these 3. Next, I'm going for this 2W, and I'm going to multiply by each 3 things again. So that is 2WN, first of all, plus 4W squared, and 2W times 1 is plus another 2W, and then 1 times each of them. Well, that's going to be the easiest one of all. It's going to be N plus 2W plus 1. And we've got at the end minus N squared minus 2N. Okay, I've gone off the side, but hopefully I'm going to be able to simplify some of this stuff now. What's gone? First thing I'm noticing, N squareds are gone. The next biggest thing I've got is a 4W squared, so I'm going to write 4W squared. Okay, I've used that, so that's gone. Okay, what else have I got? I've got 4WNs plus 4WNs, so that's this one and this one. I've got 4Ws plus 4Ws, and I've got 2 N's. That was this one, and is that other one right? So, and this one, And what am I left with? Some numbers. So that is just a 1 times 1, which was 1, plus 1. So 4WN, 4W. So in fact, this is looking like this, but I've got an issue. Something's gone wrong, because I'm looking at this, and if it were to expand, the 4N times W, 4 times W as well. So I'm expecting these, but I wasn't expecting this one here. So let's just have a little look. Oh, is it? It's this minus 2n here. I didn't take that into account when I was adding up my n's. N plus another n, take away 2 n's, and that can happen. It's nice to have these show that questions, because you know if you've made a mistake. So I can get rid of that minus 2n, that's gone. And what have I got on the end here? It was just a plus 1, which can be rewritten as 4w squared plus 4 lots of n plus 1 w plus 1. Okay, find the width of the grid when T9 is equal to 51501. Okay, 4w squared plus 4n plus 1 w plus 1. Does that have to equal 1501? Okay, there's a little bit more information in this. Actually, when I look at it again, n plus 1, it actually tells you what n is. N is 9 in this instance. So we've got actually 4w squared plus 4 times n plus 1. If n is 9, it's 10. So 10 times 4, 40w plus 1 equals 1501. What I'm going to urge you to do here, because we haven't studied quadratics yet, is to use your GDC to solve. If you're unsure about how to do that, then that's a good thing to ask your teacher. Use part 1 to explain why Tn must always be odd. Okay, right. Now this one's quite a straightforward one. It seems really complex, but what you've got and you've been given is the 4w squared plus 4n plus 1 w plus 1. What we've got is we've got everything's being multiplied by 4, or if you like, we could rewrite this entire thing and take out a factor of 2 from here. So if I rewrite this as being 2 lots of 2w squared plus 2n plus 1 w, I need to fit in as well, plus 1. Basically what we've got, this thing, because it's multiplied by 2, is even, and so when we add 1, it must be odd. And we're done. Good job, guys.